All right. So, what alphabet letter is the uterus shaped as? An O, an A, or a Y? Y, nice. So this is the catheter. At the end of the catheter is a cuff. So we're going to pass that into each uterine horn separately. So we're going to start in the right uterine horn. We're going to blow the cuff up. That's going to occlude the top 2/3 of the uterine horn off. Okay, that's where the embryos are. We're going to flush collection media in. Embryos are going to float out in the collection media. And Tony, because she's athletic, is going to catch them in that cup. That cup has a filter in the bottom of it. Embryos at day 7 are 120 microns in diameter. So that's going to come in important later. Don't forget that number. And the bottom of that filter is a 70 micron filter. So water can go through, embryos stay in the cup, and we can find them. History says they used to catch them in tubs and let the water sink, or the embryos sink in the water, and then they decant off the top, and then they'd go find them. The filter makes it a lot more efficient. Okay? Crawl through, Tony. We're going to collect the right horn first. So since you guys haven't figured out how to put a camera in the cow, we'll just talk through it. So we're going into the right horn through the cervix. Trying to get far enough down the right uterine horn that the cuff will hold it, the catheter in place, but not so far that we pass where embryos may be located. At that point, we blow up the air cuff to hold it in place. What shape are embryos? You guys seen pictures? Circles. They're round. Nice. Good. So catheter's in place. At this point now we just start infusing fluid in. So at this point a uterus doesn't have any fluid in it. Embryos are just setting in the distal or top third. So we're trying to dilate the uterine lumen by adding fluid, getting it to expand, trying to make sure we push that fluid clear to the tip of the horn, increasing our chances of recovery. As the fluid comes back out, Tony's just catching it. So 120 microns, how big is that? Besides saying 120 microns. Can you see it with the naked eye? Can we count them coming out? Nope. But it doesn't take large magnification to see it. We're going to start with 20x and get to, by the time we're evaluating the embryos, we're looking at them at 80x. So 80 times magnification. Do 2 here. We use stereoscopes instead of maybe the typical monocular. The reason is we're worried about temperature, right? So our light source is directed off a mirror to try to avoid heat from going directly onto the stage where the embryo is. So if you look at the microscope in there, you're going to see the light source is in the back. It's pointed at a mirror that's reflecting it up to where the eyepieces look down. It would be really cool if these things had GoPros on them and we could see them come out. That way we knew we had them. Let's do 2 here. So it's just about kind of doing a process, repeating the process, just like AI, right? You can't really tell if you successfully got the cow pregnant when you AI her, but you know that you followed these rules, these steps, and over time you see what allows you to have success, right? So that's just what the collection process is. We don't know what it is until Toby tells us when we get in there and start looking for them. But we know that we use this amount of fluid. Let's do 2 again. We go in and out, which means we push fluid into the uterus, we get it out this many times. So we think all of that, the process of flushing fluid in and out of the uterus, the process of using so much volume of fluid in the uterus, are all things that matter when it comes to recovery rate. So that's what we're just replicating here. Do 2 and quit on this side. Clamp. On collection day, we're also worried a lot about temperature, direct sunlight exposure, all those things. So environment matters. These embryos are pretty hardy, but at the same time, anything can cause the day to go bad. So it's nice to be in a nice barn like this today. We do have to do it outside in the elements. It's getting to be less common that way as ET has gotten to be more of a common practice. Seems like more people have setups that allow us the chance to be the most successful. Tony likes that a lot too because it's not as cold, not as windy. All right, so that's the right uterine horn has been flushed. We're going to come out, we're going to restyle that up. Go on the left side. If you guys, participated or watched the donors being bred, maybe you've also watched cows being bred at home or somewhere else, and you've seen that things can be done differently and still have the same outcome, right? So there are multiple ways to conventionally flush a donor. We collect horns individually. Some people just blow the cuff up in front of the cervix and flush both sides of the uterus at the same time. So that is called a body flush. The catheter and the cuff are placed in the uterine body. In that scenario, you have to use a lot more fluid. And maybe takes a little bit longer. Really, for the most part, though, it's just who you learned this from and how you were trained on which side you pick. The guys that learn bodies usually do bodies their whole career. The guys and ladies that do horns probably stay that way. So, like I said, there's lots of ways to do the same thing. Collecting cows is no different. But that's the two main ways to do a body collection, to do each horn separately. Okay.
Have you ever done a body flush?
Every now and then, but typically not. The guys that do that are usually shoot side by themselves. They're hanging bags, have tubes that put larger volumes of fluid in at the same time. The team or the side of the ET pool that I learned from, let's do 2 here, feel like using less fluid into the uterus is important. It's not something that's supposed to be in there. We do know if you would repeatedly collect a cow for years without her getting bred, at some point she won't get bred, and that's just because there is some scar tissue that will develop from pushing fluid into her uterus that many times. So our goal is to be the least invasive and the most efficient as we can for the donor that day, just hoping that lets her be a donor longer.
Is there a certain advantage or disadvantage to doing full body flushes?
Most of the time, those guys, I would say, let's do 2 again. Advantage is you only go through the vaginal vault once, so the chance of taking debris into the uterus with you is reduced. If we, at day 7, those cows, if we take something in, if it's a dirty environment, we are going to cause a uterine infection to occur, which is detrimental to her getting bred back. Let's do 2 and quit. So I think the body guys will say that that's maybe why they choose it, less risk of contamination by going through the cervix and the vaginal vault twice. Truly, it's just who taught you and how you learned.
fluid are you putting into each horn?
So we're somewhere around 300 mils, 250. We'll use half a liter. If you are doing the whole body or the whole uterus at the same time, you're using 1 to 2 liters. So definitely a higher volume of fluid. We'll use about a half a liter per donor.
How many times can you flush one in a row before you kind of need to read them back to make sure they can still breathe back?
So a lot of people it's changed over the course of time as the genetic turnover has gotten faster, but we used to collect cows 6 times a year, twice or every 60 days, and then breed them back, and they would usually breed back pretty efficiently. So I think that's kind of at the top end. A lot of people today just go from season to season, so they get 3 collections. And then you can talk about all kinds of things today with IVF and doing stuff after they're pregnant. So there's lots of ways to flush each cow less. Plus with the genetic turnover, most of our clients are trying to get less, they're trying to collect more cows less often than 1 cow more often. And that just gives them a bigger genetic diversity on their embryos that they're putting in. Sometimes if the left horn stimulates more, but really it's just a repetition thing. I think I would look like I didn't know what I was doing if I went the other way. Usually when your left hand is in there, you push things so that the right horn is easier to hit. So a lot of times that's just where you go first and then you collect the other one next. But good question. So conception rate is less with an IVF embryo. They cost more to make, but you can control things. You can control gender better. You can control calving interval. You can have the donor pregnant when you're making the embryo. I think both are necessary. If you're okay leaving the cow open a little bit, a conventional embryo will have a higher conception rate and it's cheaper to make. But it also takes a little bit more work, as you saw. The process takes a while. Great question. So we're just trying to predict response. So we're palpating ovaries, seeing how big they are, trying to get an estimate of CLs that are present, because for every follicle that ovulated, there should be a CL today, right? So we're just palpating ovaries to try to determine response, cleaning her out, getting uterus kind of situated. We are giving an epidural that should keep her from straining on us, should keep her from, once we get the area clean, from it getting dirty again. But our goal is to just be as clean as we can and get out as many embryos as we can. So we try to have goals. We don't want embryos without a plan. If we're going to freeze them, we want to collect and have them frozen within 3 hours. So that means we can collect 5, 6 cows at a time, and that'll take us about 2 hours. And then we have an hour to process, get them in the freezer, and then we can start again. So to do that in a day, you can only really do that 3 times. We've tried 4, but it's a long day. So 18's usually our top number. Sometimes we'll do 24, but somewhere in there.
How long do you have if you're going to put them back in the freezer the same day?
Right, so that number probably varies the most. We say we want them back in within 5 hours. Before we were successfully freezing them, they would spend a long time out. Like they would collect them in the morning and maybe fly them. I can remember stories of colliers flying embryos to another state to put them in. So then they were out maybe 10 hours. I do think, they're not in culture media, they're in what we call a holding media. It has basically it's the right pH, it's the right osmolarity, but it doesn't have any growth factors to help them grow. They just are in a stable state. They're also not in elevated temperature, they're at room temperature. If we would get them to body temperature and put them in culture media, they could probably last longer, but most of the time with conventional ET, we're just holding them at room temperature. Our goal is to have them back in within 5 hours. Today we'll hopefully beat that. The average is 7. So every cow that gives 7 is average. Every cow that gives more than 7 is my favorite. Right, great question. So 7 viable embryos out of a total Usually of 13, 14. We're usually 50% fertilized. So of all of our structures, half of them get fertilized. Great questions, guys. This is going to be fun. So serosal muscle layer, and then the endometrium. If you stretch it too much, you can tear the endometrium, and then you won't get good recovery. At that point, you'll start getting a lot of blood back. Basically, you just feel them kind of tone up, which would be like feeling them like they're in heat that day. You can feel that as you're adding fluid to it, but it doesn't. Like this cow's uterus is like the uterine horn's the size of your thumb, and we're not going to make it much bigger than that. We're just going to feel it firm up. Good question, though. It's not cool. It doesn't blow up like a balloon. Yeah, so, well, with semen, like you're saying the semen's in the water bath, and then it gets bred as fast as possible.
A lot of them that could kill it.
Yeah, that's...
So why aren't there so many that could kill these?
That's a great question. I think we're lucky that way, right? Yeah. That we have a little bit of time. I think every time that the animal or the embryo or a fetus gets further along in gestation, they become safer, right? So the oocyte, like the sperm cell, is very temperature specific. So when we're aspirating donors, we're really worried about temperature control and all that stuff. As we get to the day 7 embryo, it's a little bit more hardy than the oocyte or the sperm cell, so we don't have to worry as much. But we do know we can create problems. If we were outside in negative 30-degree weather trying to do this today, we would be in trouble. So we would have to move donors around, haul things around. So, but good question. I think as they get older, they get more durable when it comes to temperature and things like that. But we can talk about IVF too, and we are temperature specific. We're keeping tubes warm, keeping fluid warm. We even have much faster time intervals there where you have to get them in to certain media as quick as you can. And it's a crazy fun world full of lots of goals, lots of timelines.
What's the most viable embryos you've pulled from a cow before?
I think for me it was in the 40s. Like I think 44. I think Dr. Gray back in the day would talk about collecting a beef master cow. They gave 70 some.
Out of how many embryos were they?
I don't remember. Of the 40, I think it did get into the 60s of total structures found.
In one collection?
Yeah. They did put all those in. Typically, when you get that many, maybe they're not going to end up getting them all in, and they just set in the tank for a while. But those 40, I think, made 27 calves. Really? Spread out over a year. It took them a little bit to get them in, but pretty much eternity. Nobody, like they have some just science backing that says that maybe after 100 years they would be less viable, but we don't have frozen embryos that are that old yet, so nobody knows. They talk about worrying about radiation exposure or some craziness. What do you think of this? We were at a guy's place and he wanted to change out his embryo tank. So he took the canisters out and put them in his freezer. Is that the same thing? No. Huge temperature difference, right? Great question. Yes. So as we get younger in age of donors, typically, especially if we're talking yearling heifers, we will average less embryos, so get closer to 4, which maybe is rounding up. Sometimes it's 3. And those embryos, for one reason or another, across our industry, it is definitely said that those embryos have a lower success rate. Right. So those animals typically produce less embryos, and those embryos make pregnancies at a lower rate. So I think that's a great question too. Typically the donor side, people are taking care of them pretty well. So I do think if you would collect young animals like first calf heifers that are thin, then yes, you could see lower quality embryos, and those embryos would be less successful. But most people that are spending the time and money to collect the donors are feeding them really well. It's maybe the recipients that don't get as much care, which is just as important, right? The embryo, making an embryo is hard enough, but if you put them into recipient cows that are not ready from a postpartum interval standpoint, from a body condition standpoint, that basically just aren't cycling yet, that aren't ready to get pregnant, then your success will be poor as well. So managing the recipients is just as important, or honestly more important, as managing the donors, so that you can successfully get live calves on the ground. So once we get to recipients today, we'll talk through that. But it is huge to be successful. A lot of people pick mature cows just because they're easier to handle, right? They don't necessarily need as much feed. They're usually in better shape, and those are... But in today's industry, where everybody has less cows than they want, most people are trying young cows again just to try to have more access to recipients. A lot of people, as the heifers start being utilized to grow the cow herd numbers back, heifers get utilized as recipients, and then we have to deal with that, which also brings back, chances at lower conception rate. Definitely, as you start to use heifers, your conception rate will go down. So our goal is to say that our fresh embryos are doing 60% or better, and our frozen embryos are doing 50% or better. I think at some point, so you have two different variables, right? Like today, we have the embryo variable and we have the recipient variable, right? So let's do two. If the embryos, which, fresh embryos should give you the best chance to get as many cows pregnant as you can, right? We haven't done anything wrong to them. We're just taking them out of the cow and putting them back in another one. So our goal is that now we get to maximize the success of the recipients, because that recipient pool, regardless of everything, environment matters. All of that affects what she can accomplish, right? So if we put in embryos that could do 70%, but the recipients that day had problems and only could do 50%, what are we going to do? You're going to do 50%. You can't, the lower number doesn't make the higher number better. You just are using one of the two numbers. So you're trying to maximize them. So if you have recipients that'll do 60% or better, and you have fresh embryos that'll do 60% or better, that's the day you have a chance to do 70% maybe. If you start utilizing things like heifers as recipients, you start utilizing things as heifers to produce the embryos, then you're lowering that chance. All right, guys. Good questions, though. This is awesome. On the next cow, while we're collecting, we're going to talk about why we're at day 7. If they pass a ring, then you have to let go of the uterus to let that go. Basically, we start every collection and or transfer with an epidural, and we're just putting 5 to 6 cc's of lidocaine, 2% lidocaine, in the epidural space, which is where the spinal cord actually ends, and then nerves branch off as they get back into the sacrum. But our goal is to prevent her from struggling to be able to pass rectal rings, so she can't poop on us, she can't pee at that point, and that allows us to maintain contact to the uterus. So like when we have the uterine horn in our hands, if she's blocked, she can't pass a ring and make us drop it, right? And that's to keep us from, maybe as we have the gun in there getting ready to transfer an embryo, from having to let go and lose the control of the gun, and now it's maybe hitting the side of the uterine wall and allowing us to maybe have some damage or blood. And we don't want that when we're collecting or transferring. So it's just going in between the coccygeal vertebrae with a needle, and then putting lidocaine in that epidural space so that it can have its effect, which is to cause the nerves to not be conducting impulses, right? So they don't work for a little bit. At some point she should lose, yeah, so she's losing her tail tone. If you were to give her a shot back here, she wouldn't feel it now, which sometimes is nice, guys, right? Do you ever have one kick while you're giving FSH shots this time? Or all of your cows are perfectly nice? So what about, and this is a vague, broad question, but this is what we're trying to answer, right? Why does a cow just have one calf? This is your question. We're making her look like a pig today, right? She's having multiple embryos produced, but in Mother Nature, they decided she should just have one, right? So what about her reproductive cycle causes that? That's a crazy hard question to ask. So we're going to just start working through it, right? So on her ovary, what is on an ovary? Are like obviously follicles are on an ovary, right? And we will talk about a term called antral follicle count. And what that becomes is that becomes the average number of follicles that are present in a follicular wave, okay, of a cow. So how many follicular waves does a cow typically have in a 21-day estrus cycle? Did you guys talk about that? Could have 3, right? I think the more common number is 2. Okay, but 2 to 3 waves per cycle. That wave, first wave starts the day after they're in standing heat, right? So she's in standing heat. The next day, what happens to her? She's in standing heat because she has no CL present and she has this dominant follicle present on one ovary. Let's say the right one, right? So when does she ovulate that follicle? If she's standing in heat on a Monday, on Tuesday, that follicle goes away, right? And we're not going to worry about that one, right? That one is like, say that's our start heat follicle, right? So on Tuesday, that follicle, dominant follicle ovulates, so the suppression effect has gone away, and now we get this new follicular wave that starts to grow. And in that is some number of follicles, and it's different for each cow. That's what we call the antral follicle count. Some cows give, 20 embryos, some cows give 10, and that is the difference. The 20 embryo producer has a higher antral follicle count than the 10 embryo producer, okay? So on Tuesday, that next follicular wave starts to grow, and you have that whole antral follicle count has the same, all those follicles have the same chance to grow, right? Somewhere in there, one of them starts to get bigger faster. It becomes closer to dominant, and as it does that, it's producing 2 hormones. You guys know what they are? What's the hormone that's in the follicle? When you ultrasound a follicle, you see it's black. It's full of fluid. That fluid is estradiol, right? And she's producing estrogens. Right, let's do 2 here. Estrogen has a negative feedback effect on the hypothalamus, right? It suppresses GnRH release, right? As that follicle gets bigger, it also produces another hormone called inhibin. Inhibin blocks FSH receptors at the follicle level. So as that follicle becomes dominant, it starts to produce more estrogen, it starts to produce more inhibin, and it is starting to force, let's do 2 and quit, force the other follicles to not have as good a chance to continue to grow, okay? So that's how that follicle wins, and that's why a cow ovulates 1, right? So what we did here with these cows is you got them in heat, and then if you would have done the math, you would have seen that we waited roughly 9, 10, or 11 days post-heat to start them on shots again, right? So that coincides with when the second follicular wave starts. So that first follicular wave started on a Tuesday. That follicle grows, becomes dominant, and around day 9 or 10, it goes away. Why doesn't it ovulate? Because of what structure that is also present on the ovary. And it's producing another hormone. The CL, right. So the CL is still present. The CL formed from what structure?
The dominant follicle that was released on Tuesday.
That ovulated on Tuesday. Nice. Yeah, good job. So, because progesterone is present, because the CL is present, because that allows progesterone to be elevated, that first follicular wave doesn't ovulate. It just becomes atretic, goes away, right? So now, as soon as that happens though, now you have this next wave of follicles that can grow, and that's called the second follicular wave. So that is what you guys used for these cows, right? Around day 10, day 9, you started giving them FSH shots. What we're trying to do is beat the cow. We're trying to flood her system with FSH so that more follicles have a chance to become dominant, right? FSH has a short half-life, so we have to give it multiple times a day so that we can keep her FSH blood levels elevated, so that we can keep more FSH available at follicular levels so that we get more follicular growth. And as that first cow showed, we grew 15 or more follicles. That's assuming I got them all out, right? And of those follicles, 9 were viable embryos, produced viable embryos. So on the second follicular wave, there's no dominant follicle. We start flooding it with FSH. By day 4, if you would ultrasound those cows, you would see, like that cow had 15 or more big follicles sitting on her ovary. At that time, we would be excited. We'd be loving life. We'd be thinking this is a win. So the other thing you also do, there's one other drug. Shoot. Can you go get me a bag? That's what happens when I talk too much. I run out of media. So there's one other drug or hormone that you gave while giving FSH. What was that? Anybody remember? You give follicle stimulating hormone, you give folitropin, or you gave 2 shots of another drug. Anybody around for that? It would have been on the 3rd day, morning and night. You added 5 cc's of a drug called Lutalize. What's Lutalize do? It lyses the CL, right? So that CL that's present is now going away. What happens when the CL goes away? Progesterone falls. What happens when we have lots of follicles present on the ovary? We have high levels of what hormone? Estrogen. So all of that being said, when all of that happens, we get the donor to be in heat. And that would have happened last Thursday. Throughout the course of Thursday and Friday, while those donors were in heat, you guys were AIing them, right? How many times do you AI your average AI cow? Once. When do you do that?
12 hours after standing heat.
Right. And why do we do all of that? What's the reasoning behind waiting 12 hours?
They release that egg after they're in standing heat.
And how far is that? We just said that. You started that with this conversation. Ovulation occurs how long after standing heat? 24 hours, right? So we're breeding them 12 hours after standing heat. Why? What's the difference? That's true for classes. That's true for lots of things, right? But why? Why is that important to the cow? There's something that has to happen to the sperm in the uterus.
It goes through all.
What's the term? Undergoes a process called capacitation so that it is able to fertilize the oocytes, right?
Yes.
Nice. So that's the timelines. So all of those things still happened on these cows, right? They were in heat on Thursday. You started breeding on Thursday through Friday. They were ovulating on Friday. You had capacitated sperm present at the site of fertilization today as we can. That is maybe not how we would always approach it. I think if if we were trying to maximize the number of embryo or number of kevs made out of these total, how many 292 give us? 9. We would transfer the grade 2s fresh, and we would freeze the grade 1s, just because frozen grade 1s do better than frozen grade 2s. And that would give you the most ET kevs out of those 9 total embryos. But my goal today is to try to make as many kevs as we can in this group of cows. So we're gonna try to put the best embryos in that we can to make that happen, okay? So that was part of the decision-making process. Those happen every day. Like that becomes the sorting. Like, how are we gonna decide how to do this? Do we wanna make sure that the frozen product is as good as it can be, or do we wanna try to maximize what we can do with the recipients that day? So we're gonna freeze 6 on her. We've made up labels. Those labels give us all the information that somebody would need to put these in. Stage and grade, reg number of the cow in the dam, freeze date, all that fun stuff. So as she rinses these, she is moving them around in that capillary tube. That is a 5 microliter capillary tube. So every time she pulls fluid up, she's moving 5 microliters. We're putting it in 1/2 ml of fluid, right? So if you do the math, that creates the 100-fold dilution. So every time we take 5 microliters out of 1/2 ml and we move it into a new 1/2 ml volume of fluid, we're creating a 100-fold dilution. When we do that, we're trying to delete out viruses, we're trying to delete out bacteria, we're trying to dilute out anything that could potentially cause disease. So the rinse process helps us to prevent spreading disease through ET, okay? Kobe, why don't you tell them you're starting a new cow right now, right?
Yes.
Why don't you talk them through it?
First thing I'm doing is labeling all the plates so we don't mix up embryos. That would be very bad if we did different cows. So every cow gets a new capillary tube for sanitary reasons. And then I go in here and all of them are in well 4 of the original plate. That's where we put the good ones. Yeah. So I'm going in here and I'm looking at them, and since I know we're transferring all the good, I'm taking out all the, these are all stage 4s, which are just morulas. So I'm gonna leave the grade 1s and I'm gonna pick up the grade 2s and rinse them out and then have them in the plate that we're gonna freeze on.
Ooh, thank you. So once we get the ones we're freezing in the freezer, we'll show you guys the ones we're going to transfer fresh, okay? So at that point, everybody will get a chance to see embryos. Does anybody not know what they're looking for? Anybody not seen a picture of an embryo yet? Everybody seen an embryo? Nice.
What size straw?
So they're loaded in quarters.
Okay.
This is, we put our labels in 1/2 cc straws and then seal those to the 1/4 cc straws so that each embryo, when you would pull it out of the tank, would list everything that you would need to know about that embryo. So you're going to see her start moving and loading them here in a second. Right now she's grading them, getting them through the rinsing process, and just staging them for the next step, which is freezing them.
Anyone have any questions?
What is the difference between like your number 1s and your number 2s? What are you looking at too?
This guy's loaded.
Good.
Did you plan this out?
No.
Good question.
Off the cuff?
So, in order to be a grade 1, they have to have 15% or less degeneration inside of the zona pellucida.
What do you mean by degeneration?
Degeneration, that's just cells that haven't developed. They've kind of just sloughed off of the main cell mass. So, yeah, basically, I'm just trying to decide whether or not they have
All right, this is where we get a draw, right? Can we
more
flip
than
this?
15% or less.
Can I squeeze in here and draw? What about markers?
I got you.
Got stuff on the desk. Scissors.
All right. So, it's not a perfect circle. What's this called? This is the outside of the embryo. What's that called? Of the material within there. It has to be an intact cell mass. So, the way I look at it, you take this cell mass and you divide it in half. You can put all this debris that's in the perivitelline space on one half of that cell mass. It's better than a grade, or it's a grade 2 or better, right? If you can then divide it into quarters and then divide those quarters in half, you now have this area, right? So if your extruded cells, your degeneration fits in this small area, then it's a grade 1 or better, right? So that's just trying to predict outcomes. It's trying to tell us how good are the embryos that we're getting ready to put in so that we can try to predict conception rate, okay? When she talks numbers, that's the numbers. A grade 1 has 85% or more of the material within the zona pellucida is still an intact cell mass, still growing, still trying to be a baby. To be a grade 2, it can be a lot less, right? It can be 50%. All right, makes sense? Questions? When we start looking at these, most of them today are probably going to be morulas. You have any 5s? A couple 5s?
Yes. Yeah, I'll ask
So a
you.
morula doesn't have a blastocele cavity. It just has this cell mass. You're going to see it within the zona pellucida. As they get older and they start to develop a blastocele cavity, we're going to see this trophoblast cells show up with fluid around them. Like we said out at the chute, this is forming the amniotic sac or the birth sac over the kef. This is the kef right here, okay? As this continues to grow, as these embryos get bigger, you're going to see that blastocele cavity grow, right? And as you get to be at stage 6, the cell mass has been pushed way down here, and the trophoblastic cells surround the zona pellucida, and this is all blastocele cavity, right? And that is trying to create pressure that's stretching that zona so that it'll hatch, okay? Questions? At that point, this is the cell mass. So when it was a 4, you can see the cell mass, you can see the dead cells, right? When it's a 6, you can't hardly see the cell mass. It's basically an embryonic disc now, and all that degenerative material shows up around the outside, so it's harder to visualize. Tony is moving them to ethylene glycol right now. Ethylene glycol is the cryoprotectant, okay? They need to be exposed to the cryoprotectant for 8 minutes. So she's putting all the embryos that we're freezing into their own plate, into their own cryoprotectant, which is ethylene glycol, and our timer has started. So now one of our races occurs. So you'll just have to hand back to me and I'll seal it. So what does a cryoprotectant do? Once we put the embryo in there, so cell membranes of embryos are permeable, things move in and out, right? So cryoprotectant is basically a sugar. So there's no ethylene glycol in the embryos. Once we put them in there, all the ethylene glycol is outside, it's going to start trying to move in, right? We need that to happen. We need ethylene glycol to get within the cells so that we can lower the freezing point of that embryo so that we can pull this off and start doing what we're doing. So she's loaded them into straws there. When we load a straw, we are loading them so that you can find the embryos. So when you load the straw, it's a long straw. We're going to load it so that there are 2 air bubbles and the embryo is in the middle column, okay? So this is the cotton plug. This is what pushes the embryo out. Toby's pulling up holding media, grabbing some air to separate that from the ethylene glycol. She's grabbing the embryo that has ethylene glycol, or the ethylene glycol that has the embryo in it. More air column, more holding media, and then Tony is sealing this and then putting the label on it. So when you see the straws before we plunge them, that's what they're going to look like, okay? So we've started the race. They're exposed to ethylene glycol. The time's ticking. She's putting them in straws. Because of that, we know what stage and grade they are. Toby's grabbing certain ones, and Tony is putting the correct label on them so that we know when we go to transfer them, we know what I'll hand them to you. How about that? We know what stage and grade we have, okay? So as the ethylene glycol is moving into the cells, some water is moving out, right? So what the biggest problem for freezing an embryo ultimately is water. What percentage of an embryo is water? Is it a lot or is it a little? Same as all biological tissues, right? Are they high in water or low in water? High, right? Yes. What happens when water freezes? Makes ice. What do you think ice does to cell membranes, to organelles? Is it good for it or bad for it? Blows them up. Nice. It definitely ruptures things. It cuts cell membranes, causes problems, right? So our goal is to try to get rid of as much water as we can. So that process starts once we get them in the freezer. So for the 8 minutes that we're loading the embryos, we're letting equilibration happen, right? Ethylene glycol is moving in, some water is moving out, but all of that is just allowing us to set the embryo up so that we can take water out, we can dehydrate it, okay? So in the end, you're looking for the zona pellucida, right? It's gonna be kind of see-through, gelatin-like, okay? And then in the middle of that, you're gonna see the cell mass. So before you guys quit looking at the scope, you gotta say, I know what a zona pellucida looks like, and I saw the cell mass of one of the embryos, okay? Otherwise, you just look in there and like, I just saw a speck. Okay, it could be something else, but I'll make sure you guys see those two structures, all right?
Okay.
Why don't you just slide over, Toby, and then you can be sitting there if they have questions.
So I put them in order. I put them in order from biggest blast on top to the smallest on the bottom. But all of those are 5s because the top one, the blast is not more than the cell mass.
Yeah,
if that
and
makes sense.
The bottom one is just really, really small.
Super tiny, but there is a blast, so that makes it a 5.
So it doesn't matter if it has like a very small blast to it as long as
Nope.
it has one?
If it has any sort of blast, that makes it a 5. And then if the blast is larger than the cell mass, so more than 50%, then it's a 6. Right now it's about 5.5, almost
So
6. But
60x.
60x?
The 10x eyepiece, and then she's turning it up based on, it can go to 80. Every day it's a fine line sorting. Like how do you sort recipients, how do you sort embryos, and you're trying to make as many KEVs as you can make. Because that's important to you guys. That's how you guys take your program to the next level, right? Improve genetics, make more KEVs, whether they're ET, whether they're AI. So I think if you had all of them in heat, we kicked out 3, I think you're doing well. The 3, one was probably cystic. It had a follicle that just went away when you touched it, so I'm sure she was in heat. She just didn't ovulate it.
This is the type of debris that will come out of their uterus. Yeah, and I just have to search through all of that trying to find embryos. To the naked eye, it just looks like mucus, but under the microscope, you can see what it actually looks like. Sometimes there'll be like a hair if it like fell into the filter, or just by using my Drummond or a syringe and needle. I'm like going through it, just looking. I like the zona, to me, kind of glows in the microscope light. It's my eyes like trained to catch it. But not only that, but usually embryos are like a perfect circle, and you don't really see that a lot within the debris. So I'm just looking for those 2 things as I go through it.
I thought we'd do now is we talk about what just happened, okay? Because all that has to happen pretty fast. So as we put them in the straw,
Pretty much.
they're loaded like this, right? So
I think
cotton
all of them
plug,
are 4 ones,
embryos in
except
the
for that
middle,
last
these are
cow,
air
they're all
columns.
5 ones.
They're still
All
setting
of
in the ethylene glycol, so we have a time limit. If they're in the ethylene glycol too long, we'll start to see conception rate fall as well. It can be toxic to the embryo if held in it too long. So that's the 8-minute timeline. Our goal is to get them in the freezer quickly after the 8 minutes is up, okay? So as soon as they were loaded, Tony was sealing the label on the top so we know what the embryo is, who it belongs to, what the stage and grade is. As soon as that 8 minutes is up, we plunge them into the freezer, right? So they go from room temperature to -6 degrees Celsius. At that point,
Okay.
they're pretty safe.
All 4 ones except
Metabolism
for
is
this
pretty
cow
much stopped.
has a 5-1
We're not
and 2
harming
4-2s.
them by being exposed to the ethylene glycol anymore because we've cooled them down so much. Okay?
And then that last cow,
so
the
as soon as
712,
that happens,
these are all 5-1s.
we're going to do a process called seeding,
712.
where we're going
They're
to
all-
take cold
Yeah, 4
hemostats,
5-1s.
something that's really cold, we cool it
But
in
everything
liquid
else is
nitrogen,
4-1s.
and we're going to touch up here in this column. And by doing so, we're going to get ice crystals to form, right? Because we're sitting below freezing, right? We plunged embryos into a plastic, or embryos are in a plastic straw. We plunged them in there. At that point, this fluid is still liquid, okay? But when we touch them, we create a colder environment that starts ice crystal formation, all right? Because we're already below freezing, that spreads. So if you watched, you would see ice crystals spread and go down the column. That takes a few minutes. We set the timer for 4 minutes, and at 4 minutes, we want to make sure that there's ice crystals around the embryo, okay? It's going to continue down the straw until ice crystals are throughout the medium, okay? And then once that 4 minutes is up, we start the freezer, and it's going to drop at 0.5 degree a minute, okay? Until it gets to -35 degrees Celsius. And then we're going to plunge them in the liquid nitrogen, and they're going to be technically frozen, okay? So they don't freeze until we get to -35 and we plunge them in liquid nitrogen. This whole process that we're doing here is dehydrating the embryo, trying to get the water out, okay? So how do we do that? We do that by creating osmotic gradients, right? So our first osmotic gradient was created when we put them in the ethylene glycol, right? We put them, an embryo that has no ethylene glycol inside the cells, and we put them in a concentration that was high in ethylene glycol, right? So now there's an interchange, right? Ethylene glycol is going to go in, some fluid is going to come out because it has to replace itself, right? What happens if just ethylene glycol rushed in and nothing came out? Cells would swell, right? Nice. So we don't want that to happen. So once the equilibration rate happens, which is what takes 8 minutes, they're in there, they're at -6. We've seeded them, we've started ice crystal formation. We get ice crystals to form around the cells, right? So when ice freezes, it's in a fixed fluid volume, right? And ice freezes, what is left behind? Is it a more concentrated fluid or is it a less concentrated fluid? Why? Who said less? Did you say less? No. You said less. So you have fluid, you have salt, right? You have NaCl, right? In water, right? So the water freezes. So one of these goes away. There's less water, same amount of salt. So
No,
it's
I
more
get that while they're in
concentrated,
the freezer.
right? So we create this osmotic gradient, whereas when water freezes, it leaves down a
Yeah, you
higher
could. Just leave
concentration
pink
of a
tabs.
solute behind,
Here's
right?
these.
So if you have less salty fluid inside the cells and more salty fluid outside the cells, where's the water going to move? Everything's trying to reach equilibrium, right? So it's going to come out. So every time we cool this ramp, every time the ramp goes down, every time it gets a little colder, more ice is forming. That's creating a more concentrated osmotic gradient outside the cells. So that's slowly pulling water that's inside the cells out. So for the next hour, while that freezer's slowly ticking down to -35, we're pulling water out of the embryo so that when we freeze them, there's less water in the embryo, right? That's what we said was harmful to them when we freeze, right? And when we freeze fast, so they go from -35 to -187, just like that. You plunge them in there. So when they freeze fast, they make small ice crystals. So by having less ice crystals in the embryo, by freezing them fast and getting small ice crystals to form, we've created a situation where we can take embryos, we can freeze them, and then we can thaw them at a later time and be successful with a pregnancy, right? All because we're able to dehydrate the embryo. The only reason we can dehydrate the embryo is because we set up an osmotic gradient to pull the water out. Make sense? It's kind of cool, right? That was probably a what? 5th grade science book chapter about osmotic gradients and permeable cell membranes, right? But it still applies today at work. It's kind of cool. So when they thaw, the same thing has to happen, right? Now you have a dehydrated embryo that has ethylene glycol in it, and we need to switch that around. We need to get water to rush in, and we need to get the ethylene glycol to come out, right? So that happens when we plunge them into the water bath, right? We bring them back down to a elevated temperature, body temperature. Ice thaws, okay? We're gonna kick them out in the uterus where there's no ethylene glycol, so the ethylene glycol is gonna come out of the embryo, okay? The cool thing about ethylene glycol is it has a small molecular weight, so it crosses cell membranes pretty readily. We used to freeze embryos in glycerol or DMSO, and it didn't move very fast. It had a heavier molecular weight, it was slower. So when we did that, we had to go through a series of dilutions to rehydrate the embryo. Because what would happen if you had a high concentration of a cryoprotectant in the embryo and you thawed it into an environment that had no cryoprotectant out here? Where's the water gonna go? It's gonna go into the cells, right? Because there's no cryoprotectant outside. We gotta dilute out the cryoprotectant that's inside, but it's so big it doesn't move very fast. So then water would rush in and those cells would burst. They would swell and burst. So if you heard of 3 steps thaws or glycerol, embryos frozen in glycerol, those are the ones that we have to thaw and then rehydrate under the microscope so that we can take them through a series of dilutions. They start at 10% glycerol, we take them to a plate that has 7.5% glycerol. Then we take them to a plate that has 5% glycerol, and then 2.5. And all we're doing is slowly changing that glycerol concentration within the embryo so that water doesn't rush in as fast and cause the swells to burst, or the cells to burst.
Do you thaw a straw like a frozen embryo the same way you would like a straw seed?
Today, if we freeze an ethylene glycol, which is called direct transfer, that allows us to freeze or to thaw shoot side the same way. If it was frozen in glycerol, we would thaw the straw physically the same way, but then we would cut it out and move it through this rehydration process so that they're still viable post-thaw, which just takes a lot more time. That was, I mean, sometimes you can get people to freeze them in glycerol today. That was probably more 80s, 90s type of ET work before they developed, or before they figured out ethylene glycol, before they learned how to use that as a cryoprotectant. Glycerol was the most common one for a while. Just took more work. You had to be at the scope the whole day, rehydrating embryos 20 at a time, transferring them. Great question. Yeah, our goal is, especially with ethylene glycol, since they're still within the cryoprotectant once they're thawed, we want to transfer them as quickly as possible. So if we were thawing embryos today, which we're not, luckily we're putting in all fresh, you would see a shoot side, they would thaw an embryo, I would already have the cow ready, and as soon as they've loaded it in the gun, we're transferring it. They have seen that if it was setting in a transfer gun for 10 minutes, that you're going to start to see conception rate fall. Our goal is to have it transferred within a minute or two post-thaw.
How long do you thaw for like a water bath?
So it's 20 seconds is what we thaw an embryo for, and a little bit lower temperature. So 30 degrees Celsius, most semen is thawed at 38 Celsius, or body temperature basically. We're a little cooler than that, and for less time. Somebody probably has a really good scientific explanation for that. That's just what the world has done the whole time I've been involved with it. Great question. So when do twins form? Obviously it's a known deal, right? Like the embryo doesn't pick that. Oh, I need a friend. Let's have 2. But it happens after day 7. So that embryo hasn't split yet. If identical twins are gonna happen, we're gonna put them in, and then they can be born that way still. So that happens sometime after day 7. Every now and then we think we can see it start to form, like you'll see 2 blastocele cavities forming, because that cell mass has got to divide. And yes, at Gardner's, we will take a blade and cut the cell mass in half and transfer both halves. Tony is the one and only person right here that does our splits. So she is the one that puts the fresh embryos in a plate,
You guys want to see a picture?
Does something change if you try to split those embryos?
Yes.
How, like,
Our goal is to be at half. So the reason gardeners would use it would be to try, they have more recipients than embryos, and if frozen embryos are doing 50% and we can do 50% with splits, we're doing the same and we're getting to transfer more embryos into their cows. That is their goal, to make more calves. Really the goal, I think, is if you have 8 embryos and you split all of them, you're making 16 transfers. And if those 16 transfers get pregnant at a 50% rate, you made 8 babies out of 8 embryos. If you put in 8 whole embryos, you won't make 8 babies. So if you have a large volume of recipients, you can make more ET calves by splitting them. You can also make less, because every time we mess with Mother Nature, she reminds us that sometimes she does better or knows more than we do, and it doesn't work as well. So most people don't take the risk of splitting. They have more embryos than they have recips available, so put in the better, or the best chance. Give that cow the best chance, right? When you have lots of cows and maybe less embryos, then you can think about splitting. The cool thing is making identical twins is awesome when it happens, right? Now they're selling identical twins. That used to be maybe more important. Today it's all about selling the best one, right? So sometimes identical twins, one's the best one and the other one's not. So what does that mean to the one that's not? It's just worth less. I think what Adelaide did here in putting some in out of every cow gives you the best chance to have the most diversity, right? To have the best chance to make the best one out of each mating. So, got to see if they get pregnant, then you got to have them born alive, then you got to do some genomics, then you got to sort them out there, then they got to make it to weaning, then they got to pass a BSE, and then somebody has to like them enough to buy them.
Don't stress us out like that.
Wow.
And then they gotta work after something.
Then somebody buys them, yes, and they got to work for 1 to 10 years, because they still may call back and complain if they don't work for 10 years. I don't know. But all of that is improving genetics, and I think the whole industry can look back and say that over the past 20 years, past 50 years, we've definitely been improving genetics in the beef cattle industry. And that's cool. That's part of why you guys are here, right? To find a spot in the future where you want to be that helps to improve beef cattle genetics, whether it's feeding cows, whether it's chasing them and roping them, whether it's doing something like this, what Toby and Tony did today, which is finding embryos, hoping to get them in a freezer or load fresh and go transfer them. There's lots of ways to be involved in agriculture today. You're a good place to find out how to start that. It's awesome.
So splitting the cells, do you have to wait till they're at that point of when they start to separate?
That's awesome question too. We do know that they need to be, so it's harder to split that cell mass. So we want to be able to cut the cell mass in half, right? So as you've seen, as that blastocele cavity grows, it's harder to see the cell mass. So we're really splitting the best embryos that are morulas, right? So Tony is taking this 4-1 embryo that looks like that, and she's putting it on a dish that has media that basically sticks it to the dish, right? And then she's setting the point of the blade here, and she's compressing the zona, because this is a sphere, right? It's got a beach ball around it, which is this zona, right? And she's compressing that, so she sees this widen as that happens, and now she knows she can gauge a little bit, is she in the middle or not? Because when she drags that blade, she's dragging that blade across like that, cutting through the zona and trying to cut this cell mass in half. So we want them to be compact. If they're not, if they haven't undergone compaction, all those little cells just fall apart, and that's not good. Once they're compact, then we want to try to cut them in half so that we give each half the best chance, because we know less cells has less chances to make a baby. So we want to definitely split them before they get too big, before the blastocellular cavity grows, and then we can't see the cell mass as well. But that's a great question. The KEF itself,
Yeah.
as far as what doesn't work, like they're just
Just like sometimes I know from back at home, like we have ET cats, and every once in a while we'll get like one that's deformed or really small or just something weird happens.
Yeah.
Is that very often?
So I think that exists in all populations. I think that sometimes with ET we're just replicating that more. So maybe it shows up more because of that. But I do agree, we're also messing with Mother Nature. And I think you see less of that with just natural matings.
No.
You maybe see more of that with AI. You definitely start to see more of that as you get into the ET sector. And if you get into the IVF sector, you could see more of that. Like every time we take Mother Nature out and we try to manipulate the system, we definitely believe we can create some things. It's a pretty low percentage. But, and nobody knows, was it gonna happen anyway, right? But it definitely is more, it's a higher percentage in IVF, it's a higher percentage in conventional ET than comparing it to natural matings. So it does exist. It's disappointing when you see it, because you got them that far, right?
We've talked about IVF a few times. What's like advantage, disadvantage, your thoughts on IVF versus ET?
So big advantages are you can do it more often. So you can go every week, every 2 weeks. That's aspirating them to conventionally collect. You're usually every 45 to 60 days. So we're changing the ovary size. So we got to get the ovary back down to normal size. And then we got to wait a little bit, then we can do it again. So you can make more embryos faster with IVF. You can control gender a little bit better with IVF. You can use sorted semen. You can take unsorted semen and run it through the sorter and expose certain genders to the oocytes. So you can control gender a lot better than conventional ET does. You can work on pregnant animals, which is huge. A lot of people want to get their cow bred so that she calves the same time every year, and then they aspirate her after that so that she makes ET calves. So there's some huge benefits for all of that. Conception rate is less. It costs more to produce the embryos. And in my opinion, there are higher incidences of late term loss, maybe big calves being born. Like there is some other things that come along with IVF that exist that some people don't want to have to deal with.
What is conception rate with IVF?
I always say fresh embryos should be 50% or better. Frozen embryos should be 30% or better. With conventional, we say fresh embryos should be 60% or better. Frozen embryos should be 50% or better.
So you're really kind of pushing going to frozen IVF.
Yeah, and you could figure out ways to make your frozen IVFs be half, be 50%. But you got to put them into good recipients. You got to be particular on what you freeze. And all of that is just our industry learning, like how to make that IVF embryo better. It's happening every day. They're 100 times better today than they were 15 years ago.
Do you do much for IVF? Or
Yeah. We
see quite a few different places?
Yeah, we still do, like out of our total workload, I would say 60 to 70% of it's conventional ET, 30 to 40% of it is IVF. 5 years ago, it was 90-10. So it's definitely growing to do more IVF.
Do you think it'll become more popular in the next? There you go.
I think IVF continues to be utilized. I think in our hands, I don't know if it won't ever be all IVF. So there's your split. You see the line, that's where the blade's cutting through the plastic as it's coming across. You see the zona pellucida cut in half, and you see perfect 50-50 cut on either side.
What is on the top, on the outside? Like
It was probably some debris that was within the zona, or, I mean, at that point, I don't think that's debris from the dish. We've rinsed that embryo a lot. I probably just
Here's the
throw it out.
blade. What happens if you can't get an exact 50-50 split? Is that a problem?
I think it just affects conception rate on the one that's smaller. So to try to give your best chance at getting 2 pregnancies out of 1 embryo, you need to be as close to 50-50. Is it perfect? I mean, look at that. How do you do that? You know how small that is. That's a perfect split.
How small is that? Not like, what size is that blade?
Oh my god.
It's got to be like.
It's a tiny blade.
And then there's 2 right before I loaded it, so then that's back into the leaf
She's
well, and then
spread the splits out. One's at about 3 o'clock and one's in the middle of the plate towards 6. So great. I didn't know we would talk about splits today, but great question, guys.
there's another one before I load them. And then this is the cutest dog ever.
Lefty.
Is it your dog?
No, he's one of the gardeners.
Landon's
Landon.
guy.
So if you ever go there.
Who would guess Landon had a dog? I mean,
Welcome to Show and Tell with Tony.
Huh?
I said, welcome to Show and Tell with Tony.
be careful.
Oh, I'm like, I have pictures. So yeah, there's another one where can you see the zona? How it's split?
To the right.
Yeah.
So when you split, this lead to...
This is awesome, Tony. You need
the
a.
calf in the future?
What was that?
When you split, could it lead to like deformities in the calf in the future? Or...
I don't know if they've ever. I don't feel like anybody's ever linked that to anything like that. But what's cool is these cells at this point have not determined what they're going to be, right? Because your question could be valid. Like, is this calf only going to have 3 legs because we cut one off, right? What's that term for when cells have not determined their actual fate in life? Isn't that totipotent? Something like that? Those cells are still dividing. They could be anything yet. At some point, as that cells divide, as the embryo continues to grow, now you have heart cells, muscle cells, bone cells, right? But pre-day 7 or around day 7, day 8, every cell has a chance to be anything because we can cut them in half and still make babies that, like you said, don't have problems. What if you made one and one didn't have a head, right? That's a problem. But it doesn't happen.
When you cut them in half, it's half of that doesn't have like a zone close around. Does that close back up?
Yeah.
So we will see, if you culture them long enough, you'll see them circle up.
So they will close back around now.
But the zona usually doesn't even go with them. Early on when they were doing this, they thought the zona was important. So they would make sure the zona was there. Then they learned over time, zona is just a structure, it's gone. They just load the cell mass.
You need to have it when you go to put that in.
Early on when they...
Snatching in day 9 anyway, you don't have to have those 2 days.
Right. Right, but they didn't know that early on. So they were cutting oocytes or unfertilized ovum in half so that they had extra halves of zonas to put with them in case they lost one or didn't like one.
Yeah, well, there's just
But then they learned over the course of time. Because a lot of this, unfortunately, isn't really researched from a scientific level. It's researched in a usage level. So there's not studies with cross references and other sides. Like, this is the control. We don't have a ton of controls because nobody wants to spend the money or time to do that. So back in the day, they were figuring that out. They were just putting zonas in with them to see, and then at some point they decided try not, and conception rates stayed the same.
Are you still able to freeze calves like the same way or no?
No, you got to put them in. It's all about cell numbers, right? And if we cut them in half, we know the freezing process is going to destroy some cells. You got to have.
Which is the only reason you would split if you have 2 heat resets for the number of eggs hands.
Basically, in our hands, that's why we use it. Some people would split, like if it's a high producing dairy cow and they want to make as many kebs out of that one mating, that's a reason to split. Back to the 8 embryos make 8 kebs thing.
tissue stuff in the box.
What do you think, Toby? You're making canes. I think we're ready to put these in before they set out too long. We good with that? Okay, let's roll to recips. So, when would you expect to see these cows back in heat? How many days from the day?
it.
Right.
'Cause, like,
So plus or minus,
my buddy and
I always say plus or minus 5 days from that. Some of them come in a little early, some of them come in a little late.
like first week of June.
So sometimes we'll have people check return heats so that we can transfer more embryos if we're coming back in 3 weeks.
Then they bring her back, try to get her later. And so this is all summer going.
Will you tell them what you're putting in each time, Tony?
A lot of people do to like build up their embryo.
Yeah, Adelaide's gonna be probably writing it down.
You guys just did a lot of work. No, I mean, we still have work to do, but it's just not like.
They're all gonna be 7.5 to 8
Because
days.
like a lot of people, like, well, just like today, they want to.
Nice, Tony.
They don't want to freeze them. So.
So if we're transferring some embryos that are stage 5s or older,
Yeah, it's
would
like
you
a
put
lot-
them into your
Summer's
older heats
basically just
or your younger heats?
Transfer to them either
Older
in the
heats,
fall or
nice.
the
So that's what Tony did. This cow was in heat on a Wednesday morning, so she grabbed our oldest embryo to put into her. So right now we're going down the right uterine horn, just trying to get as far down as possible. Transfer it and get out. Most of the time we don't pre-palpate those, so we're just palpating
still
them
see
once
it?
and done. But if we know we're gonna have to freeze, we don't like to
Do you need a
let the
focus?
ones that we're gonna freeze set the whole time we're transferring. We want to get them in the freezer so that we're not just leaving them on the counter. So they have a good chance to. So then we're trying to determine what we're gonna do fresh, get them in the freezer, and then finish.
Yeah.
Right, nice.
Yeah.
So that's what we
So once I get
call a
in, then
Sandy
I
shield. That
push
just
it
gets
out
us
and
to the
push it out.
cervix without
Get all
having
those air bubbles out there,
the
just kinda go up
gun
and down a little
exposed to
bit.
the stuff that's in the cervix. So it's trying to just make sure that when we get into the uterus, we don't have debris.
So you gotta be delicate with it. Because it will break.
Yep, exactly. I think you definitely can find cows in each breed that do better and worse, but I would say traditionally semis, Angus do pretty good.
So yeah, kind of cool, huh?
Yeah, and like also like the little moves, like I can understand that too. Like when you like go in, all of a sudden you're like, shit. Because the little movements is a lot.
Mm-hmm.
So I can understand like too, like if you're like, oh shit, it's right there, wham! Breaking these things every time, I can see that.
Oh, yeah.
Too.
Right. So it's just, to me, that's what feels normal, because I transfer to mostly 7-day cows, so if I felt a toned one, I'd be like, this uterus feels horrible.
You have to pull it straight, get it back in, loosen it up, and then
They
just
are
pull it
pretty
off.
flaccid.
So just
How many people have AI'd here?
Oh, I thought it was just loose. Oh, that was a little hard.
Few? Lot?
Well, this
Nice.
one,
Is that, you guys have a class here to learn how to AI? Is that part of it? Nice.
Because I mean,
Was it fun?
they've been crazy.
I bet they do any sort of crazy.
I thought it was one of the most frustrating things in the world when I first tried. I was like, yeah, it's horrible. Cows straining on you, pooping on you, and they're supposed to do what? I think it depends on the level of stress. I think you could. We always tell people it's better to move them sooner than later. So I think we worry about stress a week later more when that embryo is expanded, it's hatched, it's starting to say, I'm here. So it's secreting interferon tau. We know that cortisol can block that, and then the cow will come back into heat. So I always say get them out the next day or two, within the next 5 days, ideally, and then let them be a cow for a while. If you can't do that, we say keep them in until they pass over. So 3 weeks.
Does that make you feel better?
Yeah, well, I'm waiting for it to fall off.
Right two.
You guys the cameraman? That's okay. Is that recording? Did you press record? I don't remember.
It's not flashing. It was flashing.
The light's on, you're good.
As long as like it's blinking, that means it's going.
So just based on which side has the CL. So like her left ovary has the CL. So we need to put the embryo in the left uterine horn so that it can block the cascade that causes that CL to go away. So as the embryo hatches, as it placenta starts to form and grow and it's producing interferon tau, that's the signal that says there's a baby here, and to maintain the CL versus it go away. So if you put it in the wrong side, your chances of all of that happening is a lot less.
How far do you go up that horn?
Trying to get as far as you can. 70, 80% is the goal. I don't know if it's ever been tracked. It's hard to know exactly where you're at, but I think people that do this a lot feel like the further you go in, the better chance you have. Grew up on an ag operation that was a registered Hereford/Angus deal, and we did ET. So I knew I wanted to go to vet school, was trying to avoid playing with cats, and this let me, so growing up, I went to like county fair, state fair, stuff like that, production sales, and knew that those were the type of people that I liked and wanted to be around. And if you're a veterinarian and you're in one town, maybe you get to work for 3 or 4 of them, but not every day. And this type of job lets you work with that beef producer every day, and that looked fun. Straws are there. The top goblet just has all the information. So this was Kansas 712 was the donor. Apex was the sire. There's 3 embryos in the cane. Tells you what you would need if you're thawing them that day. Fill out all the stuff, all the ABC forms, so that when somebody wants to go and register Kev's born. So then the embryos are just in the straw in the bottom goblet, and everything's just held in there like that. We can put 5 in a little cane, 9 in a big cane.